It was recording like most of it though.
Alright, welcome back. This is the problem we're analysing, and we're just saying what's the force in BF, or DF actually. Okay. The answer is that is a zero force member. Unless you actually apply a force at that node there. Okay? So that makes it easy. Immediately that's a zero. That's a zero. We can take that out. Okay? So it's like the truss will behave the same if those members are actually just not there at all. Okay? So that's good. Alright. Then let's have a look at F. Oops. I want an eraser. Anyone?
No. Use the back of the pen.
To move things around.
If you tap it, can you just press X?
Delete. Boom. Look at that. Thank you. All right, let's look at member, look at joint F. F has that, it's got a load hanging down there. It used to have zero force members right there, but because they're zero force, we don't really care about them. All right, what can you tell me about the vertical component? That's F, that's C, that's F. What can you tell me about the force in member CF? Be more specific. All right, if I covered up that force there, what can you tell me about that member?
Force negative.
Yeah, if it had no force there, that would be a zero force member, right? But it has got a force, so that's a vertical component only. There's no possible way that that member and that member can support the vertical component of that force there. So all that force is exactly the same. Whatever's there is exactly the same as in there. Okay? Because that's pulling down, that one is going to be tension. Everyone happy with that?
Yep.
Okay. We should probably put a number on it. What are the numbers that, because everyone gets different numbers for this, what numbers do you get, Jake?
For the whole length of it is 8, and then
Okay, so that is 4. That is 4. How tall is it?
3.
That's 3. And what's the force? The forces you got?
I've got 95.
95. What for that one?
Yeah, vertical force at the center, bottom joint.
95. And for this one?
Horizontal force at the top of the joint, 50.
50. Okay. All right. Now, all right. So that's 95. So therefore, that is 95 in tension. That's 95, and that is 95 in tension. Okay? Can everyone see that? Okay, if 95 in tension, is CF going to get longer or shorter? Thank you, longer, yes. All right, anything in tension gets longer. All right. Okay. If we are going to work out that, it doesn't actually matter what that force is. These members are irrelevant to that at the moment. Okay. All right. I guess we have to work out the reactions next. We probably should have worked out the reactions before we even got to there. Someone want to shortcut me and do this on paper and tell me what the reactions are? We've got 50 there. That's the horizontal, that's easy. And, alright, I'll show you a shortcut. That's 95. Ignore the 50 for a minute. That's 95, that's going to be the same. So that's 95 divided by 2 is 42.5. And 42.5.
47.
Sure, you're right.
47.5. This is why you check. Thank you.
Should we ignore the reaction force that's pushing across?
I was ignoring that one for a second.
Oh, you're ignoring,
Okay. So that's 50.
Like,
Now,
yeah.
let's work out what happens to the vertical reactions from that 50 force. Let's ignore that for a second.
Yeah.
Okay. We have 3 times 50 is 150. Okay. Trying to do this. Okay, let's think about rotation around A. We've got 50 kilonewtons there, 3 meters above A, trying to swing the whole truss around that way.
Negative.
Yep. And resisting that, we've got 47.5 pushing up 8 meters away. Okay? So we've got 150 minus 150 plus 47.5 times 8. Actually, that should be 3 times 50, if we're going to be accurate. Can someone do 47.5 times 8? 380.
Yep.
Alright. So minus 150 plus 380 equals 0. Sorry, no, hang on, that's not right. What are we trying to do here? That doesn't equal 0.
Did you forget the reaction?
Ah, yes, thank you. Plus, yes, I was looking at it. Okay. We have 95 pushing 50, pushing that way. Resisted by that times 8. What are we trying to find out here?
I don't know.
I don't know.
I just account for it at the same time.
Yeah?
The horizontal at the same time, so just have it as one moment.
Okay. We have to put that in. No, because I've already taken care of that with the 47. Oh, sorry, it's not 47.5. That. Okay. Yeah, there we go. Okay. Again, delete the last 3 minutes. Okay. Let's have a look. We've got 150 pushing that. Okay. It's going to ring me in the middle there. Okay. Plus a reaction for C, plus a reaction for C. Okay, the 47.5 is just dealing with that, right? So we've taken care of that, so we're ignoring that for a second. So we've got minus 150 plus the reaction C at E. Reaction E pushing this way. So that reaction E times 8, come in. Okay, what's 150 divided by 8? Equals 0. Reaction E equals what?
18.75.
18.75. 18.75. Okay. So that is 18.75 plus 18.75. Okay, and to make that, that's also going to be 18.75. So I've taken a monumental shortcut here. I've left myself no way to check it and contradicted my earlier statements. Everyone happy with that? Sorry? All right. It might be a good idea just delete all this and do it again properly. Okay. Now, guys, I've got to stop briefly for a meeting at 10 o'clock. Take like a 15-20 minute break, and then we'll come back to this, okay? Sure. All right. Look, do you want me to go back and do this again properly, or are you happy with those reactions?
Should be right.
She'll be right. Okay. What's 47.5 plus 18.75? 66.25. Okay. And
deflections, right?
what is
Which one is that?
47.5 minus 18.75?
Fourteen.
47.5 minus 18.75. You're looking confused, I'll explain why I do this in a second.
28.75.
28.75. Okay. 28.75.
Oh, wait, that's just true. No, that's just true, I think. Because that's possible.
Okay, you have a legitimate question. If you're thinking to yourself, what the hell are you doing here? That is a reasonable question. Just to recap, what we did was we ignored the 50 for a second and we said, what are the reactions from the 95? We got 47.5 each. Then we said, all right, ignore the 95 for a minute. What are the reactions caused by this 50? And we got the 47.5, 18.75. Then we added them together and we get that, okay? Because for the 95, they were both, 95 is down, so both of those pushing up. The 50 was going that way. That's trying to roll the truss over, so that meant an additional reaction was needed here, and additional reaction pushing down was needed there, which is why we get a lighter force there than there. Cool with that? All right. We have those forces there. Now, we can come to, now we have to go through the truss joint by joint, okay, to find out the member, the force in every member. And what we do is we isolate a joint, and we want to isolate joints where we have only one unknown, okay? We've already done this one, that joint there. So that's given us that one there. We've already got that force as 95. And so we can go to any other joint now, I guess. If we go to that one, we know that angle, so we can go to that one. We know that angle, so we can go there. We don't need to go there. Okay, we've got two unknowns here, okay? So we can't do any more on that joint. So let's go to this one, E. All right, joint E. What's that angle?
37 degrees.
37 degrees. Okay, and we have a force of 66.25. Okay? Now, the force in this member here is made up of a vertical force and a horizontal force. Okay? So this is DE. So the force, the horizontal force, so DE horizontal equals whatever DE is times either the sine or cosine of 37. Okay? Now I have to look at it to get it right. If it was a really narrow angle, the horizontal force would be the cosine of the angle. So it's going to be cosine cos of 37 degrees. Which means that DE vertical equals DE times sine 37 degrees. Does everyone get that? Do you want me to go there again, or is that? If this is confusing, speak up now. Okay? So that's the vertical. That's the horizontal. So look at this. Which one do you want to do first, vertical or horizontal? Oh, okay. Hang on. We have to do the vertical first. Because we have a vertical force and one vertical reaction. This one, whoops. This is member FE. FE has no vertical component because it's horizontal, remember, right? So let's look at the vertical forces. Sum of all the vertical forces is 0. So that means that DE times sine of 37 is equal to 66.25. DE equals 66.25 divided by sine 37. What's that equal?
$110.08.
110.08 kilonewtons. Okay? And, alright, because we have DE, we can immediately work out DEH. What is DEH equals 110.08 times cosine of 37 degrees. And what's that equal?
87.91.
87.91 kilonewtons. Okay, that's the horizontal component of that member there. Let's look at the whole joint. We've got a horizontal component from FE. FEH equals the same thing as the DEH. DEH. Okay? The horizontal component of that is the same as the horizontal component of that, which means that's 87.91. So we're over here. This is 87.91, and this one is 110.08. Okay? Now, tension or compression.
D is compression.
Sorry, DE is compression. DE is compression. And so FE is, sorry?
Tension.
That's compression, means it's pushing in, so that must be pulling away, so that is tension. Okay? Very good. All right, so we have that one now. We will go through the same process to work out that one. Just remembering there's a 50 kilonewton force there. And then we go, if we go to joint C now, we now have 110 there. We've got 95 there. We've got an external force of 50. And so we can work out that one. Because we work out some of the horizontal forces. The horizontal component of that is the only unknown. Because we've got a horizontal component of that. We've got a horizontal component there, we've got an unknown horizontal component there. So we can work out the force member in that force. Okay? Does that make sense so far? Okay? And then, so you have to go through steps for each joint, and then make the big table here. So we've got the member AB, BC, CD, DE, where are we? AF, FE, and BF, and DF. I think that's all of them. And we know that these two, we work out the force in there, and either use positive for tension, negative for compression. Then you know these ones 0 already, and then you work out the change in length and then the new length. Okay, and then redraw that slightly. Okay. Now it should not surprise you that joint F is going to go down slightly. Okay, we've just hung a great big weight on it. Intuitively look at it and go, which way should this deflect? I'm expecting joint F to go down. If you work this out and joint F has gone upwards, you probably made a mistake. Okay? You're pushing on that thing there, you'd expect joint C to go that way a little bit. Okay? Just think about, you push on it, things tend to move that direction. Okay? It's a bit harder to say what happens to joint D, that's alright, but you know, F is going to go down, C is going to go that way. Use that. Alright. We need to take a break now. Let's break for 20 minutes, and then we'll come back and do a bit more on this. Okay?